Hi, this is Michael Guess, and today we're going to go over how to perform spike detection on a high channel non-1020 EEG. And to do that, I've launched Persist 13. Select the Open button, and we can pick the recording of interest. I've already done that. And now that the recording is up on the screen, I'm just going to display the full EEG hours. I already have trends configured for this recording. That can be gone through in a different screencast. Right now, I'm just going to set up the spike detection. So to do that, I want to first create a detection montage. I'm going to decrease the number of channels here using this slider so I can see the labels clearly. And I want to page down using the vertical scroll bar on the right to remove any unused channels. And here they are at the end of this chain. But any channels that aren't used or are bad, we're going to go ahead and delete those. So I'm going to right-click on this, delete selected, and now those channels are removed. Next thing I'd like to do is go ahead and save this montage, and I will call it grid or GRN1. Okay, so now I've created a montage. I can add it to my montage favorites. And I've already got a montage I created previously for this. Let's add those. Select OK, and now they're available from the drop-down list. So there's the custom montage with only the channels that I want to run detection on. And the next step is to go to Tools and Insight 2. You can run the spike detection from the P13 interface, but we're going to use the spike clustering program to look at the results for the high channel. And for that, we'll use Insight 2 to launch that. So I'm going to go ahead and select there. And in a moment, the Insight 2 program will launch. This one has a different interface. And again, instead of selecting the number of channels per page vertically, we just have an auto fit height button where we can spread these channels out. And we can still page up and down and look through them. And from the Tools menu, this is where we'll launch Reveal. So I'll go ahead and launch Reveal. And the first thing I'm going to do is set up the protocol. I've already done that, but we'll go ahead and go through that exercise. Under Settings and Protocol, here's where we can set the spike detection montage. And this is the montage that we created. Here are all the channels. Next thing I want to do is look and see if there's any codes assigned. If there are F channels in here, FP channel labels, or T channel labels, they may get a code assigned automatically, and sorting by code allows us to see that there are none of these that have a code applied. If that were the case, though, what I could do is highlight any channels that had the code applied, go to Edit Selected, and here's where I could make sure the code is set to none. The other thing I've done is I want to go ahead and remove the automatic gain control, because the gains on these are you can already see that the gain I would be reading this at would be 70, so I'll set that to 70. I'm not going to use 1020 topology because this is not a 1020 recording. And I'm not going to be using, in this case, the rhythmic burst detection, but the steps would be the same. You'd pick the montage, set the gain control, remove any codes. The Settings tab, this is where we set the detection thresholds. And for this recording, the higher the number, as you get approach 1, the less sensitive it is. So I'm going to go with some default settings of spike detection at 0.6, notify 0.9 for this. And I'm also going to select the store detailed spike information. I'm not going to be doing spike or rhythmic burst detection on this recording, so I don't need to modify those settings. Now, if you like, you can set these to a lower setting and decide if you need to have increased or decreased sensitivity for your detection. So I'm going to go ahead and set these here, close. But again, if you begin running detection on this and you're not picking up, if it's not detecting the spikes that you want, you can decrease that number and it'll increase the sensitivity. So I'll go ahead and select close. And all I have selected here in the main panel is the spike detection box. I haven't selected spike burst or rhythmic burst. Detect means that it will, obviously, that it'll place a comment on the recording. Notify means that it'll put up a message box and indicate that something's been detected. We don't want that for this. So save the protocol, give it a name. That's what's displayed here. So just to summarize what we've done, we've just created a montage with the channels we want to run detection on. We've run reveal or launched it, selected the montage to tell it these are the channels and the reference we want you to use, and save those settings. And now we can select process, and this will begin going through the recording. Under the view menu, there are some controls for how it's going to update its page time and so forth. So if we do that, then you can see that the EEG will begin paging along. There's a histogram duration. This doesn't do anything other than set the window length for the display, and it lets us see that the process is running. And so from here we can see the count increasing fairly rapidly here as it goes through the recording. And if we go over to the comment list on the right, we can select what it will show. We can go to the spike detections, and we can see those beginning to appear over on the right. Now I had set up trends for this as well, and you can run those concurrently. So let's go ahead and select the M marker button here at the top. We can split the screen. There's a little splitter in the bottom, and we could even begin trending this at the same time. And there's a guide on how to set up trends for this, so we can watch the building of trends as that proceeds. The spike detector is ahead of the trend display there. So if we turn off the update EEG page time, then we can see that the trends are beginning to build over on the left, and these are trends for rhythmicity. So let's go ahead and go back to the review tab. We'll stop the trending over here. We'll go back to the review. We can update the page time, and we can see it placing spikes. Let's go ahead and stop it here. We'll select pause. Close the reveal box. And our spike detection comments have been updated. Let's move this over a little bit so we can see that it's indicated the time, scalp sign, or rather just the sign in this case, perception, which is how well it matches the algorithm's expectations, and some additional duration, height, angle parameters for each detection. Let's go to the Tools menu and go to Spike Clustering. This will let us look at the results by morphology and topology. It'll go ahead and sort those for us. Here the N equals 2,409. If this is much more than 3,000, we can reduce that number because otherwise it will take quite a lot of time to do the averaging. Go to Tools and Filter. This allows us to set the detection sensitivity after the fact. So in this case, if we wanted to reduce the sensitivity, we could put this at 0.7. Select Shuffle. And I inadvertently put in a number in the random, but in the perception we put 0.7, and it'll set the minimum perception at 0.7. 0.6 is where we had done our initial detection. Select Shuffle. And you can see the perception bars that will clip off whichever one that we set that floor at. Now the random, we'll take a random subset of that. And so if we were to set this to 0.2 and then shuffle, we can see that the number filtered is 80% of what we originally had. So if you have an N total of 6,000 or 10,000 or some large number like that, you can either reduce the sensitivity by increasing this perception threshold, or if you want to include the lower sensitivity or lower perception spikes, you can put in a random number here, and 0.2 says, tells the program to randomly select 80%, and you adjust that number as appropriate to get an N filtered around 3,000 or 4,000. And again, what that does is it speeds the time that it takes to sort these. So select OK, and it updated that number over there. Next, we select this blue button to do the clustering. And here you can select whether you want to do it by where it's located or how it's shaped or both. The topology parameter is going by height rather than perception. Again, these are all user selectable. And for morphology, it's going to look at duration, height, and angle. And there are additional parameters as well. Let's use this as the default. We'll select OK. I'm just going to go ahead and group these according to topology and morphology using those parameters. Here's the wizard bar. It says there are 25 groups, and in some cases it will just show us a single group. In other cases it'll show us a group and two subgroups. Let's look at an example of that. So we're going to step through the averages, and if it doesn't have any subgroups to show, like in those cases it only had one in the average. So this n equals 62 says this is an average of 62 detections. And then it says a what if. It says, what if we were to split this further into additional groups? Would you want to do that? And you can see here n equals 35 and n equals 27. And what we're doing is we're looking at the morphology of the first average and then the two averages that would be created if we were to refine the groups even further, if we go another level of separation. And the morphology of these two look the same. Topology and morphology look the same. So instead of hitting expand to separate those into unique groups, we'll just click the next button. And so doing this, we can decide which groups we want to save, which groups we want to delete. And the idea is that you can decide which ones you want to keep as a group or which ones you want to delete as a group. So if you have artifact groups, you can hit delete and it'll get rid of those. Now, if you want to look at any of the individual detections in a group, you can do that as well. So we'll go up to a group where that will be of interest. And the individuals are displayed over on the right. We can sort them by perception, by focus. Again, perception, with the higher numbers at the top, those are the higher perception ones. And if we wanted to look at this in the context of the surrounding EEG, we could go to Tools, scroll the EEG page, and it's been brought to this page. We'll go ahead and expand the channels, and we can page down and look at the detection and decide whether that's anything of interest. And then we can go back to spike review. So let's say we wanted to delete that group. And then the number of reduced from 25 to 24. Same thing, we can look at any of the individuals we'd like. We can sort them. And let's say we wanted to go to this one, we go to Tools, scroll the EEG page. And we can look at individual detections in the context of the surrounding EEG. Typically, though, we'll just step through one group to the next and quickly decide which ones we want to hang on to. Delete artifact groups and keep the ones that are of interest. So let's jump to the last group. Just for now, we would go through each one of these in turn. But for this exercise, we'll just hit this button to jump to the last group, select Done. And now it displays these averages back to back. We go to any particular one. We can look at the individuals. We can sort them by focus, or by perception, or by time. And again, we can go to the underlying EEG, bring it up in Insight 2. Page up and down. And we can see that there's the spike detection we were looking at in the spike review program. We can look at detail of the selected nodes or the selected event. Again, the maps in this case, we could build maps to reflect the layout of electrodes using bitmaps and electrodes, labels, do propagation maps. And again, this is where we want to create the maps in advance to do that. But in this case, we're just going to use the leaf node traces and go through them using the waveforms. Any questions? Feel free to email, and I'll be happy to go through it via web conference as well. Thanks.